Welcome back. Today we're going to be looking at RegEx in Python. So what does RegEx stand for? Well, it stands for regular expressions. And what that means is it's a set of characters that you can use to compare strings. And the way it works is using various complex stuff, but it's not something specific to Python. It's used in all different languages. And there are lots of special things that you can do rather than just having a bunch of if statements. So for example here, this will check any letter from A to M inclusive. This will check that you've got a digit. This will match anything where the dots represent a character. So it could be HEMMO or hello. You've got a starts with character. So this is any string that starts with hello. End with any string that ends with world, 0 or more occurrences. So this will match AI, AIX, AIXX, and then any number of x's at the end. However, this one will match AIX, and then anything after the x. So you could have AIX, AIXX, and so on. This will match a specific number of occurrences. So this will be A, and then 2 to 5 L's. So if there are fewer, it will fail. If there are more, it will fail. Then you've got either or. So this will capture either falls or stays as a word. And then this will capture a group. So this is saying plus, so there's one or more, but it's got to be 1, 0. So it'll capture 1, 0, or 1, 0, 1, 0, or 1, 0, 1, 0, 1, 0, and so on. And there are a few other characters that we might come across as we look at some examples. And the way you do this in Python is using RE, which is a very uninspiringly named module, which is short for regular expressions. So if we look at this notebook, the first thing we're going to do is import re, and obviously that doesn't do anything. It's built in Python, so you don't need pip to install it. The next thing we're going to do is whenever we have a regular expression, we generally put an R at the front so that it takes the string literally. So if we look at these two examples, here it's turned /t into a tab, whereas here it's just printed it. And for regular expressions, there are times when you really don't want it to put random tabs in. So the first thing for re is find all, and all this does is it loops through and finds every occurrence. So here it's ing. And you might say, well, that's not that useful. You know, we've just found ing. We could have just used a count or an in or something. But it turns out maybe we want to find something more complicated. So this is saying look for any character that isn't a space 1 or more times. And you can see it's come up with writing code while recording a video, each one individually. And here we're looking for a digit in the text, and you see it's returned an empty list. We can also use search. So we're saying that our search is we're searching for white space in the text, and you can see that it's found one. And a useful thing about that is that we can see the start and the end characters. We also might search for a Q, and there was no Q, so it's returned none, and then because this is a notebook, it's not printed that. Another thing we can do is split it. So here we're saying look for any character that's A, E, I, O or U in the text and split it based on that. And you can see it's taken out all the vowels and split it up. And for example there, it's kept in the spaces. Another thing that's great is substitutions. So maybe you've got some extra spaces or extra new lines in your text and you want to get rid of them. Well, here we can say replace an I or an L with a 1 in our text. And you can see it's done this, and it's still kind of readable. And then here we're substituting an O for a 0 from the one that we've substituted the first time. Unfortunately with sub, you can't do multiple substitutions that are different at once. But you can do this, and you can see it's semi-readable. Another thing is match, and match only returns the thing at the start. So if we look at this, you see it only matches writing. But if we look for white space, you can see it's returned none, and that's just because the text starts with no white space, and so it's failed. So if you want to look throughout the string, use search. If you just want to check the start, use match. So now we're going to have a look at some very common regular expressions, or at least some very useful ones. And so we've defined this test function. So what it does is it takes an expression and a list of tests. It will print out our expression, and then loop through each test and print the result. So if we start with this one just looks for numbers. So you can see it looks for a digit at the start, and then 0 or any number of digits. And then it looks for a dot and some more digits, but it's got a question mark, which means 0 or 1 occurrences. So that means if there is no dot and then more digits, that's fine. But if there is one, or if there are multiple dots, it fails. So we could add some more test cases. So we could say 0.5, or we could say 1.1.1. And we haven't defined test. So you can see it works here, it works here. It doesn't work here because we've got this E in randomly. It doesn't work here because we haven't got any digits. It works here because you can see is 0 or 1 occurrences, 0 or more occurrences of the first digit. And then here it's failed because there are multiple dots. We can also test for email addresses, for example. So here we're saying any of these characters, which I think are the valid email address characters, and there's one or more occurrences of these, and then we put an andesat, and then we've got all these different things. Dot means a literal dot, and we need multiple of these, and then we've got a dot, and then we have this end domain, and this can be 2 to 6 letters. So if we run it on some of these, you can see email.com has failed because it's got no andesat. Email it nowhere has failed because there's no proper domain name. And then these other ones have worked successfully. We can also test for domains. So this one says HTTP, then there could be an S, there could not be. Then it's got a colon. It looks like it's put different slashes, but in regular expressions, a / means something. So what we've done here is we've escaped these and said treat them as backslashes. And then it doesn't have to begin with this HTTPS : / and it doesn't have to have www, but it can. And then it has a series of subdomains and domains, and then the top level domain is lowercase and only a few letters. And then afterwards we can have maybe query string operators or stuff. So you could, for example, go to kj.org search equal to Python. So if we go through each of these, you can see google.com has worked, http python.org has worked, email at test.com has worked, but it's only noticed the test.com because this part is not part of the URL, and that's why we're using search instead of match for our tests. And then you can see these other ones have worked. The text with a space has failed, the word has failed, with 2 dots it's worked, so apparently this can be a valid URL, not something I've tried. We can have subdomains. This one hasn't worked because it's got this 2 here. It's saying each domain or subdomain must have 2 to 256 letters, and you can't actually therefore buy the domain a.com. And you can see here it's worked because it's looked afterwards and said, yeah, this makes sense. Another thing you can do is Ipv4 addresses, and this just looks for the number 0 to 256. And this looks for the number 0 to 255, and then a dot 3 times, and then the number 0 to 255. And this individual code is quite useful because you can use it, for example, to look for RGB color values. So it's saying we can have the number 0 to 9. Does that make sense? That's any 1-digit number. Then we can have any 2-digit number, is 1 to 9 and then 0 to 9. And then it gets more complicated. So we can have any 3-digit number that begins with a 1, and then has 0 to 9 twice. Or we can look for any two-digit number between 200 and 49. So you can see this is 0 to 4, this is 0 to 9. And then if it begins with 2, 5, it can only be 0 to 5. And then there's the dot. And that's escaped because otherwise a dot would represent any character. And then we repeat that and then put 1 on the end. And you can see this one has passed because it's valid, this one has passed because it's valid, this one hasn't because it's too short, this one it's got 257 and 256 in, so it's failed, this hasn't got digits, this has got no dots, and this has got an E character in randomly. You can also test for dates. This is checking the first few days of the month, so 1 to 9, but it's checking you've got that leading 0. Then we're saying if it begins with a 1 or 2, it can be anything from 10 to 29. It's +/D instead of 0 to 9, just so that you can see there are different options. Then it's checking 30 or 31, and then a dash, and then 0, and then 1 to 12 with the leading 0, and then just a number at the end where it's checking for a 4-digit date. And it says it must begin with 1 or 2, so you couldn't have the date that was 3000 in there, which we can show. So if we've got, for example, the 1st of January 3000, that will fail. And so here it's worked, it's matched the date correctly. Here it's done the same thing, but it's realised that there are brackets and ignored those. These all fail for various reasons. This one because it's not 4 digits, this one because they're not 2 digits. And then these all work, and you'll notice some of these are valid and some of them aren't. So the 28th of February 2012 is valid, but the 31st of April and the 30th of February aren't. And that's why there's this one that exists, and you can see this one is a lot more complicated, and I'm not going to try and explain it because of how complicated it is. It's got stuff here like look ahead operators, which are very advanced, and this checks that the date itself is valid. And you can see it also does slashes and dots. It works out that the 28th of February 2012 is valid, 29th of February 2004 is valid, the 29th of February 2013 isn't valid, 30th of February isn't valid, the 31st of April isn't valid, and so on. It also is checking that you don't need to have the leading zeros, so this is a very useful regular expression, although most of the time now you can just use a calendar widget or something, so that it will make sure it's a valid date anyway. And then of course a simple one to end, the time. We're just checking that we've got 0 and then the 24 for the time, and then we're checking that we've got the 0 to 59 for the minutes, and then 0 to 59 for the seconds. And these question mark colons aren't that necessary, but they're quite nice way of doing regular expressions. You can see where we've got a negative sign, it doesn't like that as a digit. Here where we've got dashes, it hasn't worked. It hasn't worked here because we've got 62. It's worked here. Hasn't worked here because we've got 24, and here because we've got 61. This one's valid. This one isn't valid because it's got leading zeros, and this one is valid. So you can see RegEx is a very powerful tool, not just in Python, but all over, to check, for example, passwords, license keys, before checking that they're even correct. And it's a lot simpler of doing than having a bunch of string options. So for this date, you can reuse this line rather than having to figure out each time whether a date is valid using lots and lots of if statements. It's universal and a very powerful tool. So hopefully you've enjoyed this video, you've learnt regular expressions, and I'll see you again same time next week. Till then.